In our second video in the tutorial series on flying the A320, we will perform a flight deck pre-flight flow, ending just before we begin programming the FMGS. The flow is conducted before programming, usually with both crew members present. This flow will proceed systematically around all the flight deck panels and ensure that every switch is positioned appropriately for departure. Before we begin the flow, we should review the dark flight deck concept Airbus has embraced and provide some guidance on the color coding of lights in the flight deck. Under the dark flight deck concept, any normally operating system does not display any status lights. A quick glance around the flight deck will highlight any unusual system status, as a displayed light usually indicates some kind of issue. As a result, during our pre-flight flow, we should not see any lights on our system panels except for previous known failures and a few other exceptions we are going to mention as we go through this flow. Otherwise, all the rest of the lights on the system panels should be dark. Before we actually discuss the flow, let's just take a moment to review the colors that may be visible on the flight deck and what they mean. White indicates an abnormal switch position. For example, fuel pump switches display off in white when they are off, as this would not be a normal status during flight. Amber indicates a system that has failed. For example, the generator switch displays fault in amber when a generator fault has been detected. Red indicates a failure that requires immediate corrective action. For example, the engine fire push buttons indicate red when a fire is detected. Green indicates a system that is operating normally. For example, the APU start switch indicates a veil in green when the APU has reached full speed and can provide electrical power and bleed air. Blue indicates the temporary operation of a normal system. One of the most commonly used is the anti-ice switches that indicate on in blue when they are selected on. By this point, the walk-around should be complete and the ADIRS should be fully aligned. Look to see that the map is available on the navigation display and the IR countdown is gone from the engine warning display. We are now able to initialize the ACARS and obtain some preliminary pre-flight information. ACARS initialize. Press the MCDU menu button and go into the ATSU and AOC menu to find the ACARS Airline Operations Control menu. There will usually be a flight init button, and this can either be done manually or by pressing a data request button, which will send the request out to ACARS for this particular aircraft to find out what the next flight scheduled is. The information should return shortly. Verify that it is all correct for the flight you're planning. We can now also use the ACARS to get an ATIS to plan for our departure. And if we have not already done so, we can calculate our preliminary takeoff data using an external source or the tablet provided with your Airbus. Finally, now is the time to request our flight plan via ACARS if available. This is usually done using the secondary flight plan function. Press secondary flight plan, go to the init page for secondary flight plan, and make an init request. The flight plan request is sent out via the ACARS system, and if the airline computers have a flight plan stored for this particular flight number, it will be sent back to the aircraft via ACARS. Usually this process takes a couple of minutes, and we don't have to necessarily verify it right away. It is only necessary to ensure that the secondary flight plan has been activated before we begin our flight planning process. When the secondary flight plan arrives, check to see that it is reasonable. Check that the departure and arrival points are correct, and press secondary flight plan and observe the actual secondary flight plan to see that again the routing seems appropriate, the departure and arrival points are correct, and the total distance is approximately correct when compared to your flight plan. If everything is reasonable, on the secondary flight plan menu, we can press Activate Secondary. This copies the contents of the secondary flight plan into our primary flight plan, ready for us to begin to use for our flight. We are now ready to begin our cockpit preparation flow. Remember that, unless otherwise indicated here, most switches should be in their normal white lights out position during this flow. Our flow commences on the overhead panel, where we move down each column in the flight deck in order left to right. At the very top of the panel are some cockpit door striker lights, which should all be out. As we move down the left column, all the ADIRS should be in nav mode with all the display lights out, provided that the IRSs are now fully aligned. As we move down, we reach the CVR panel, which will allow us to run a CVR test. Ensure that the parking brake is on, or the following test will not work. Recorder ground control push button switch on. Loudspeaker volume knob off. This proves that certain sounds will override the speaker volume control. ACP intercom radio switch, captain and first officer side, to interphone. Interphone volume knob, captain and first officer side, release and set the volume down to minimum. CVR test push button, press and hold. The test is successful when an audio tone is heard through the speakers. Turn the loudspeaker back on and the interphone volume back up so the flight crew can hear future calls from the ground crew. Moving down the center column, we've already checked the circuit breakers. Don't forget to check the audio switching is at norm. This switch is often missed during overhead flows. On the first flight of each day, we must test the engine and APU fire detection systems. The normal order to test is Engine 1, APU, Engine 2, unless the APU was tested earlier. The APU test was detailed in the first video during the establishing electrical power procedure. We will detail the procedures for testing Engine 1. The procedure for Engine 2 is exactly the same, using the Engine 2 push buttons. Engine 1 fire push button switch, check, in and guarded. Engine 1 lights, check, off. Engine 1 test button, press and hold. Note the following. You should hear the continuous repetitive chime. The master warning light will flash. The ECAM will display Engine 1 fire. The fire light on the engine master panel comes on. The Engine 1 fire push button switch comes on red, and the squib and discharge lights on the agent push button switches come on. We will then perform the same test on Engine 2, and we are looking for the same results. Before we touch the fuel panel, we must check to see if the aircraft has been refueled. If the aircraft is being refueled or still needs to be refueled, we must leave all the fuel pump switches in the off position. Otherwise, hidden failures in the system could cause fuel spills during refueling. If the refueling is complete, check the ECAM screen to ensure that the fuel level is sufficient for the flight and the refueling memo is not being displayed. If the fueling is complete, turn the wing tank pumps on. Then check to see if we have center tank pumps for the A319 and A320 current engine options, or if we have center tank transfer valves which appear in the A321s and later versions of the 320. If we have center tank transfer valves, we can turn them on as well, and make sure the fuel mode select push button switch is checked auto. If we have center tank pumps, which happens in most of the older versions of the A319 and A320, these must be off for takeoff if the quantity in the center tank is less than 200 kilograms. In this case, it is 0. Center tank pump 1 and 2 push button switches off. Also ensure the fuel mode selector is manual as well if the pumps are not going to be used. If we have more than 200 kilograms in the center tank, the pumps shall be turned on and the fuel mode select push button switch shall be checked to be auto. On the electrical panel, there should be no amber lights except for the gen fault lights before the engines are started. If it is the first flight of the day, we must check the battery charge as follows. Electric push button switch on the ECAM control panel, press. Battery 1 and 2 push button switches, off. Then auto. This starts a new charging cycle on the battery. Within 10 seconds, both batteries should indicate less than 60 amps and decreasing. If the charge of one battery is not below 60 amps and decreasing after 10 seconds, wait until the end of a charging cycle, 20 minutes, and then perform the check again. On the air conditioning panel, for A319 and A320 aircraft, the pack flow selector should be selected as required. If less than 85 passengers will be on board, select low. Select high for abnormally hot and humid conditions. Otherwise, select normal flow. Note that when the APU is supplying the packs, the controllers provide high flow regardless of this selector position. For A321 aircraft, the pack flow is replaced with an Econ flow push button. The Econ flow push button is selected as required. The criteria for the A321 is to select Econ flow on if the passenger count is below 140. Similar to the A319 and 20, the pack controllers automatically provide 120% normal flow when the APU is supplying the packs. In most cases, a single pack is sufficient to supply air on the ground from the APU, so select one of the packs off during the pre-flight to reduce APU fuel burn. Both can be turned on during taxi. It is best to alternate which pack is turned off from one flight to the next to ensure even wear of both packs, though some pilots prefer to turn off pack 2, as this reduces noise on the side of the aircraft where the ramp crew spend most of their time working. Probe window heat push button switch, auto. Cabin press landing elevation knob, auto. Make sure the cabin press landing elevation knob is turned all the way counterclockwise into the auto detent. Strobe switch, auto. This causes the strobes to turn on automatically at takeoff in case they are forgotten. Beacon, off. Nav and logo lights as required. Normally the number 1 position, unless the number 1 is burnt out, in which case the number 2 position can be used. Remaining exterior lights as required. Generally everything will be off for now, though the wing light may be turned on to assist in pre-flight inspection at night. Seatbelt switch, on when the refueling is complete. This signals the cabin crew that there will be no more fueling while the passengers are on board. No smoking switch, auto. Emergency exit light switch, armed. On the maintenance panel in the top right corner of the overhead panel, all lights should be checked out. On the number 3 audio control panel, the PA switch should be pulled out and above half volume to ensure that PAs are heard on the CVR. If it's the first flight of the day, extend the compass for a compass check. On the Glareshield and main panel, we will work outside in before moving front to back on the pedestal. Individual crew members will check the settings on their side simultaneously, while the pilot flying will still continue the flow for all the central common items, such as the flight control unit, the engine warning display and system displays, and the pedestal. Barometric reference, set and cross-check. Flight directors, check on with the green light illuminated. ILS/LS button as required. ND mode and range as required. ADF VOR switch as required. Heading VS and track FPA push button should be in heading VS mode. During takeoff, if track FPA is selected, the flight director orders are not appropriate for takeoff roll and rotation. The altitude window should be set to 100, and the outer knob on the altitude setting knob should be set to 100. Some airlines prefer to always switch the outer knob to 100 after selecting a new altitude to avoid large altitude changes in case the wrong knob is grabbed inadvertently. Do not engage the auto thrust on the ground, or else an auto flight, auto thrust off fault may be generated at engine start. On the center panel, check the standby instruments. If you have the analog instruments, standby airspeed indicator check should be indicating 0. Standby altimeter. Set the altimeter and check the altitude. Standby artificial horizon, check. Ensure no flag is displayed, and erect the artificial horizon if necessary. If you have the integrated standby instrument, ISIS, check. The artificial horizon should be erect, the speed should indicate 0, and the altimeter should indicate the correct field elevation. Check there are no flags and reset the attitude if necessary. As you scan across the engine warning display, it is recommended to review all the current messages in the memo areas to determine if they're relevant. Any abnormal messages should be noted and their cause determined. Anti-skid and nose wheel steering switch, on. Clock, check and set. Press and hold the date button to display the date on the clock and verify it is correct. Verify the time is correct as well, and check it against the aircraft clock on the bottom of the system display. If the time and date are incorrect, some systems, especially ACARS, will not work correctly. Moving on to the pedestal, radio management panel. RMP, check it's on and that the appropriate frequencies are set as required. Green nav light, check off. Select light, check off. COM frequencies, tune. You can select the expected ATC frequencies on VHF1. VHF2 is normally used for company station frequencies and ADIRS. Audio control panel. Audio controls as required. You can usually turn down ATC until we are ready for pushback, but make sure the company station is up on VHF2. Intercom knob, check volume. You want to hear when the ramp crew calls you. On the weather radar, radar switch off, wind shear predictive wind shear switch off, gain knob auto or cal, mode selector weather or as required, and tilt knob select to 4 degrees up. Speed brake lever is down and retracted. Switching panel selectors are all norm. ECAM control panel. Press push button, press, and check on the cabin press SD page that the landing elevation is auto to confirm that the landing elevation knob is in the correct position. Status push button, press. Check that the in-op systems match what is expected from the MEL or is otherwise currently configured. For example, if a pack was selected off, a pack 1 off message would be reasonable. Prior to engine start, a CAT2 in-op message is typical and will disappear once both engines are started. Make sure the thrust levers are idle, the engine master levers are off, and the engine mode selector is norm. When we reach the parking brake handle, accumulator pressure, check. If the accumulator is not in the green arc, consider using the yellow electric pump to pressurize the system. However, always check with the ground crew before energizing the hydraulics during a station stop. If the cargo doors still need to be closed, you can delay refilling the accumulator, as it will happen when the cargo doors close, as closing the cargo doors also activates the yellow hydraulic pump. Parking brake handle, check on. Brake pressure indicator, check. Brakes should show pressure on both sides. If brakes are hot and chocks are confirmed in place, parking brake handle, off. However, if other conditions such as a slippery ramp exist, the parking brake can remain applied. Gravity gear extension, check stowed. Check RMP2 and ACP2 the same as for RMP1 and ACP1. For the transponder, confirm ATC is currently standby. Select System 1 if Autopilot 1 is to be used, or System 2 if Autopilot 2 is to be used, while noting that only System 1 is available during the electrical emergency configuration. Squawk code as required. Press clear and type in the code as dictated by ATC. Altitude reporting on. TCAS mode selector, TARA, and TCAS traffic selector all or above as applicable. Flap lever, check at 0 detent. Finally, we will conclude with a cross-check of the main instrument panel and a verbal cross-check between both crew members. First, check the brightness levels are okay, and especially that the ND outer ring of the brightness knob is set to maximum to ensure that radar and terrain displays are visible. For the PFD, check that the PFD and ND are not transferred. check the correct display when attitude and heading are available, and check that IAS, FMA, initial target altitude, altimeter readings, VSI, altimeter settings, heading, and attitude display are all appropriate for the current position. The tolerances for the altimeter are plus or minus 20 feet between both PFDs, plus or minus 100 feet between the PFDs and an ISIS, or plus or minus 300 feet between the PFDs and the mechanical standby altimeter. Also, if the flight will enter RVSM airspace, it must be verified that both PFDs are showing within plus or minus 75 feet of the field elevation. On the ND, check the correct display and cross-check the magnetic heading to the ND and the DDRMI. Finally, a verbal cross-check is usually conducted by both pilots to confirm they are both seeing the same indications on their PFD and ND, including a cross-check of the magnetic compass if it is the first flight of the day. Ensure you see 1 FD2, 1 FD2, altimeters 2991 inches indicating 10 feet, 2991 inches indicating 10 feet, heading 195, 195, 195, 195, 195, and 195. We have now finished our cockpit preparation flows and ensured all of the systems are correctly configured for flight. The last major preparation task is to prepare our flight management and guidance system with our intended flight, but that will be the subject of our next video. Thanks for watching.